Another video on digital electronics. In this video we'll be seeing a second method to implement a multiplexer tree. So if you remember the first method in which we had used 2:16:1 with an OR gate, we are going to use here 2:16:1 plus one more mux, which is a 2:1 mux, and see how it is working as a 32:1 mux. So we have one mux here. This is a 16:1. So 0 to 15 are my inputs here. This is my enable pin, and I have 1, 2, 3, 4 because it is 16. 2 raised to 4 is equal to 16. So I have 4 select lines: S0, S1, S2 and S3. So depending on the code at the select lines, one of the inputs will appear at the output. Same goes with the second 16:1 mux. And I'll have same select lines getting connected here: S0, S1, S2 and S3. The inputs here will be from 16 to 31. So this in all is from 0 to 31, which is 32 inputs. Again I have an enable here. So this is my G2, this is my G1, and both the enable we are giving logic 0. This is also logic 0, which means both are enabled at the same point of time. Both the mux are active. One output here. So since we are doing 32:1, how many select lines am I supposed to have for 32? 2 raised to 5 is equal to 32. So 5 select lines. So these are 4 select lines: S0, S1, S2, S3, which is nothing but your B, C, D and E. So this is my B, C, D and last one is E. So I'm missing with one of the select lines, which is A, and that select line will appear here. So this is a 2:1 mux. Since I have two inputs, how many select lines are required? 2 raised to 1 is equal to 2. So one select line is required, which is nothing but your A. And this is G3, which is connected to logic 0. So all the three, G1, G2 and G3, all the enables of all the three muxes are connected to logic 0, which means all are active at the same point of time. How is this going to work? 2:1, this is your final output. How is this going to work? Exactly same way like this mux worked. So I am taking the same truth table. I am not repeating the truth table again because the concept is same. A is 0 for first 15 inputs and A is 1 for the last 15 inputs. Again, say we want to check 17, whether I get at select line 17, whatever is at input 17, do I get at the output? How do we check that? So 17 is given by 1, 0, 0, 0 and 1, right? So my A is 1. So let's keep this A as equal to 1. So my A is 1. If A is 0, my first input will get selected because A has only two options, right? A could be either 1 or it could be 0. If it is 0, then whatever is at this input will get selected. If it is at 1, whatever is at this input will get selected, right? That is the concept of 2:1 mux. So again we are giving control to A only, like we did in the previous case. At enable we connected our A with a NOT gate, but here we are considering all the enables to be active, which means all the inputs are active. So for B, C and D, this is my code 0, 0, 0, 1. So if I give 0, 0, 0, 1, if I give 0, 0, 0, 1, which means my first input is getting selected. So first input from here, this is the 0th one, this is the first one. 16th is the 0th one, and 17th is the first one. So this is getting selected and this is getting selected. Whatever is at this input, either 1 or 0 will appear at the output. Similarly, whatever is at this input, either 1 or 0 will appear at this output. Now both the outputs are having this input, which is getting connected here at the first pin, but now the control is on A, which means if A is 0, then whatever is at this input is coming at the output, which is the code for what? Which is the code for 1. So 1 code is what? 0 0 0 0 0 1. This is the code for 1. This is the code for 17. So if A is equal to 0, then this gets selected, then this gets selected, which is 1. And if A is equal to 1, then whatever is at second input gets selected at the output. So since my A is 1 in this case of 17, I will have second input getting available at the output. So whatever is at 17, if it is a 0, I will get a 0 here. If it is a 1, I will get a 1 here. So that is the logic of multiplexer tree. So in spite of giving a control to enable, we are now putting a different mux altogether, which is a small 2:1 mux, and again giving the control to A. If A is 0 here, then all these inputs will get selected at the output depending on the select lines, which is from 0 0 0 to 1 1 1, which is 0 to 15, and again 0 to 15, all this will get selected and appear here. Now it depends on A. If A is 0, then from these first 15 I will have the output coming here. If A is 1, then from the rest of the 16 I will have my output coming at the final output. So this is the logic of implementing a multiplexer tree using 16:1 mux, and altogether is a 32:1. So this entire mux, this is your entire mux, which is having 32 inputs and a single output. So I'll stop the video here. Thank you for watching.